So all of these one-way between group ANOVAs basically are the same. You just replace the variables. So DV is cognitive test scores, continuous variable. Dosage strength sounds like a grouping variable to me. Jumping over to SPSS. Right, dosage strength, and we've got 4 different subgroups, levels of the IV called dosage strength, and cognitive test scores. They do look like they're in scale. Okay, we're ready, Freddy. Again, we're going to check the normality first. Descriptives, explore, out with you. Get back out of there. Boom. And cognitive test scores. And again, this is the one we want. Normality plots with the tests. Click continue. So we're going to look at the Kolmogorov-Smirnov test, and it was not significant. Therefore, it did not violate the assumption of normality. And again, the histogram, that does look kind of normal to me. Not perfect, but close enough. So we're going to run the test. Analyze general linear model univariate. Out with you guys. Cognitive test scores is the DV, dosage strength. Everything else here should be picked already. Let's make sure the post hoc test, Tukey. And options, right, descriptives, estimates of effect size, power, and homogeneity. That's us. Good to go. Click OK. All right, step 1. Here is the number in each group. Very important. These don't have to be the same number in each group, okay? This is just, made up data. But here's the means. So I got a high of 7.3 and a low of 5.8, 5.7, so it's about 1.6. Square root, I'm going to say, yeah, there is a significant difference in there. Levine's test, where are you? Right there. Boom. Did not violate the assumption of homogeneity variance. So in other words, the variance of the cognitive scores is relatively the same across all 4 of the different drug values there. And here is our F test. So we can explain 11 times the variance of the cognitive scores based on the drug group, which is a lot. And it is significant, big time. And we have a huge effect size, 0.626. So in other words, we can explain about 63% of the variance in the cognitive scores because of the grouping model. And our power is practically perfect, which means we're good to go. Let's see what else we got here. Tukey test, Tukey. And again, I just looked down. Oh my gosh. So the placebo is significantly different in all 3. I think that's basically all we need to know, right? And let's just make sure, yeah, it's the placebo versus all 3. So that is it in a nutshell. Hold on. A one-way between group ANOVA indicated that there was a significant difference in the cognitive test scores between the 4 different drug levels. F, 3 degrees of freedom between group, 20 degrees of freedom within group, or the error group, equals 11.17. That's huge. Let's just double check that. There it is right there. Which means that 11 times of the variance is coming from between the groups than within the groups, which is proof that the difference in the cognitive scores is coming from the grouping. So in other words, the drug seems to be working better at making these guys have higher cognitive test scores. Must have been invented by a math teacher. Effect size really huge, 62.6%. With a power of 0.996. Again, that has to be over 0.8. It has to do with your sample size and other things. And the Tukey test showed that there was basically a significant difference between the placebo and all 3 of the drug dosages. And there's the means. You can check them yourself. And the normality and homogeneity variance were not violated. So that's it. MGZ out. What I'm trying to do is get you guys to recognize what the DV is, right? That's going to be a continuous variable. And what an IV is in an ANOVA. So that's the grouping variable. And this is a between group, one-way ANOVA, right? One IV, grouping IV, relationship types. Relationship satisfaction scores are the DV. I'm going to do this faster than fast. Checking the assumptions of normality first. Out with you. Relationship satisfaction. Everything else should be checked. Going down to the Smirnov test. And according to the Shapiro-Wilks, it is. You know, you can cite that if you want, or normally we just stick to the Kolmogorov-Smirnov test, and it says it's not. And again, you got some outliers here. If you got rid of a couple of outliers, it would probably be normal, but we're going to run the test as is. General linear model, univariate, out with that DV, in with the new DV, out with that old IV, in with the new IV. Get in there, you. And post-hocs, tuki. Options, 1, 2, 3, 1. Click OK. And let's go to the top here. Boom. So here are we have 8 different levels of our relationship type variable, and here they are: celibate, cohabitating, blah, 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 right? Friends with benefits. Who put that up there? Oh, my goodness. And here's our descriptives. Oh, my gosh, you got huge, right? Other is 8. And your high is divorced. Well, actually, cohabitating, not married. Okay, married's a close second there. Let's keep going. It did violate the assumption of homogeneity of variance, so that too is bad. But according to our model, the F ratio is 35. And our significance is less than 0.001, and we have a huge effect size of 67.3%, and our power is perfect, which means our sample size is big enough. So let's see where the significance are. They're all over the place, okay? So the celibate, it is significantly different except for the single people and the married with children. The cohabitators, they are... Don't forget which column you're in. Cohabitators, yeah, they're significant from everybody except for married with no children, divorced, etc., etc. So you use this as a guide. So there's so many differences in there, I'm just not even going to mention them. And let me write it up for you. A one-way between group ANOVA indicated that there was a significant difference in the relationship satisfaction scores between the 8 different relation types. F, 7 degrees of freedom between group, 120 degrees of freedom within group equals 35.33. Again, that means that 35% or 35 times the variance is coming from between groups. In other words, it's the relationship style that shows the difference. That's the cause of why the relationship satisfaction scores are different. Okay, p-value is practically 0. Strong effect size, perfect power. Tukey test showed significant differences all over the place, so I just put that in there. So the assumption of normality was not violated according to the Kolmogorov-Smirnov test, but it was according to the Shapiro-Wilk test, and the homogeneity variance was also violated. So I'm going to give you guys a treat. I'm going to show you the non-parametric version of the ANOVA, and we should get the same results. In other words, it's going to reject the null. So we're going to go to Analyze, Non-Parametric Tests, and these are independent samples. And hold on, let me see, get this on the screen here. I always hit the run first, get the error message. Yeah. And then there's our DV, right? That's our test field. Relationship style is the grouping. We hit run, and we wait. And there it is right there. So it used a different type of test. For this one, it used the Kruskal-Wallis test. Same difference. You got a real low significance, low p-value that the null is true, so you're going to reject the null. And again, this is the non-parametric version. There's another one called the Mann-Whitney-U test, but either one. But remember, non-parametric tests are not as strong as parametric tests. But that's it. Hope it helps. MGZ out.